So it's completely fine. So we'll start our session now. Good morning everyone and welcome to Vista's Learning. My name is Dhiraj, your maths teacher. In this session we're going to discuss about triangles. I know that's a pretty tough chapter, what we think earlier, right? Because there are lots of rules, lots of theorems and we have to discuss all of them. But now, as you can understand the theorem, the chapter becomes very easy for you because you know the concepts, you know the rules, you know all the steps, right? So if you know the rules, if you know the steps, you can play with it. But if you don't know the rules, you'll struggle with it, right? So that is the thing why we have came up here. And what I have asked you to do, first attend the session, then try to solve the questions related to that particular concept, what we have discussed here. So it will become very easy for you to understand. Okay. So here we are going to discuss about triangles. So see, I understand triangle is not so easy. In the same time, it is not so tough. Only what you have to do, you have to just remember all the theorems and it's done. Nothing else. So I'll move up with that particular part. So what you can do, if you're solving it and if you're having any doubt, you can write to us at www.vlearning.in and we will get back to you, respond to you and solve your issues. If you have any questions that you are unable to solve, we are there to help you with it. Okay. So that is the thing we are going to do. So in this lecture, what we're going to do, we're going to cover the entire theorem so that the entire chapter becomes very easy for you. And then in the next class, we are going to pick up few of the most important questions from your book, exercise problems, and few of the most questions that has already came in examinations. And then we'll move ahead. Okay. So here we have a small recap of the things that we have already studied. That is, first one, what it actually is, it is the SAS congruency rule. So this shortcut name that we can use, SAS, ASA, AS, all these shortcut rules, shortcut names that we can use, that is very important. So what this actually says, two triangles are congruent if two sides and the included angles of one triangle are equal to two sides and the included angle of the other triangle. So here, what they are trying to tell is, suppose if we have two triangles, okay, until and unless we have two triangles, with whom we are going to show the congruency. So for congruency, minimum two triangles is required, right? So that is the thing they are telling us over here, that theorem 7.1 ASA, that is angle side angle. They are telling two triangles are congruent. Two triangles are exactly the same if two angles, this two angle, okay, and the included side of one triangle, are equal to two angles and the included side of the other triangle. So what we can say, we are using two angle and one side. So angle, side, angle, angle, side, angle. We are using this property, right? So here, this theorem is also known as ASA, angle, side, angle, congruency criterion. Using this also, we can prove that two triangles are congruent. Okay, so now you're getting the steps, right? So moving ahead, we have another, that is angles opposite to equal sides of an isosceles triangle are equal. So for that, first we will have to draw an isosceles triangle. What does an isosceles triangle mean? An isosceles triangle is a triangle whose two sides are equal. Okay, whose two sides are equal. A triangle has three sides, out of which two sides are equal in length. You can get it over here. So if they are equal in length, then these two angles will also be equal in measurement. So that is the second theorem. Let us repeat it once again. Angles opposite to equal sides of an isosceles triangle are equal. So this angle and this angle will be equal in measurement. That is our theorem number 2. So that all of the steps we have already discussed in our previous class. We are just doing a recap so that we remember all the steps. We don't forget anything. Moving to the third theorem, we have the sides opposite to equal angles of a triangle are equal. Okay, what this actually is, suppose I have a triangle and suppose this angle and this angle are equal, these two angles are equal. So side opposite to this angle is this particular side and side opposite to this triangle is this particular side. Okay, so this angle opposite side is this. Let us name it as side opposite to angle B is AC and angle A is BC. Okay, so you have understood. So what they're trying to tell, if these two angles are equal in measurement, okay, if angle A is equal to angle B, then AC will be equal to BC. So that is our third theorem. So I hope you have understood this thing very clearly, right? It's too easy. Let's move to the things that we have to start from this particular class. Okay, so there are some more criteria for congruency of triangles. So till now we have studied three, and that were very easy as well as very understanding. So that were very easy. We have understood the steps. One was the angle side angle property, then isosceles triangle property, then converse or opposite of isosceles triangle property, right? But now onwards, all the things we are going to cover in this particular part that we are going to study now. So what is this? That is SSS congruency rule. Let's discuss about congruency for a while. What do we mean by congruency? Or if we are discussing about congruency, that means the angle, the shape, the size, the length, measurement, everything should be exactly the same. Nothing should differ. Suppose if I have a two triangle A, B, C and X, Y, Z. Suppose I have this two particular triangle. So if the length of AB should be equal to XY, AC should be equal to XZ and BC should be equal to YZ. So all of the lengths should be equal. Okay, first thing we got. Second, angle A should be equal to angle X, angle B should be equal to angle Y, angle C should be equal to angle Z. So angle as well as the side, all of them should be equal. Then we can say that triangle ABC is congruent to triangle XYZ. Then only these two triangles will be congruent, or else no, they are not going to be congruent if anything misses out. Okay, so here what we have got, theorem 7.4, SSS congruency rule. In this, they are saying if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. Okay, we gave the name as A, B, C, X, Y and Z. We gave this particular name. So what that is, if AB is equal to XY, AC is equal to XZ and BC is equal to YZ. Okay, I will write it down. AB is equal to XY, AC is equal to XZ and BC is equal to YZ. Okay, if these three sides are equal in measurement, so we can say that triangle ABC is congruent to triangle XYZ. I guess I have become too big. I'll become a bit small so that you can see it more clearly. Okay, so that is the congruency rule. Okay, now by what property are they congruent? Question arises like this: by what property are they congruent? So by side congruency criteria, we can say that these two triangles are by side congruency criteria. We can say that these two triangles are equal in measurement, equal in length, or what we can say, they are directly congruent. Fine. Let's move to the next theorem. That is our theorem number. What is happening? Oh, fine. That is our theorem number 7.5. So in theorem number 7.5, what we got is, if two right angled triangle, the hypotenuse and one side of the triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. So you can see, I'll name it as A, B, C and D. Okay. So we have got two triangles ABC and ABD. We have got two triangles, triangle ABC and triangle ABD. Fine. In which angle C and angle D are perpendicular or 90 degree. Okay, this angle we are taking to be 90 degree and this angle we are taking to be 90 degree. So these two angles are 90 degree. So what we are getting is, if two angles of two different triangles are 90 degree each and the hypotenuse are equal in measurement as well as their one side is equal in measurement, then it is congruent. So right angle hypotenuse side, in shortcut we call it right angle hypotenuse side. In shortcut, what we are going to call it? We are going to call it RHS congruency rule. So that is one of the criteria how we can say the triangles are congruent. Let's move to the next theorem, that is theorem number 7.6. So there are in total 8 theorems that you have to learn, and that is actually very important from your examination point of view. Not only up to class 9, in class 10, 11, 12, it is going to help you a lot. Don't miss it out. Okay, so theorem 7.6. If two sides of a triangle are unequal, the angle opposite to the longer side is the largest. I'll just change the color of my pencil. So what they're telling, suppose I have a triangle ABC, okay, and all the sides are unequal in measurement. Okay, all the sides are unequal in measurement. So the longest side, that is AC, in this particular triangle, you can see it over here. The longest side is given, the angle opposite to the longest side will be greater. It will be greater. Any triangle that we can draw, suppose that is a triangle that we have drawn, so that is the longest side. So angle opposite to the longest side will be greater. So that is the thing we have got in theorem 7.6. I hope you have got it very clearly. Let's move to the next theorem, that is theorem 7.7. Here, in any triangle, the side opposite to the larger angle is the longer, just opposite to it. So if I have a triangle, I'll name it as A, B and C. I'll change the color again, this time a bit yellow. So A, B and C. We have these three sides. Now what? So we are telling that if the angles are different in measurement, okay, angle number A, angle number B, angle number C, that different in measurement, and angle B is the greatest angle. Angle B is the greatest angle. Then the side opposite to the greatest angle will be the longest side. The side opposite to the greatest angle is going to be the longest side. That is our theorem number 7.7. That we can say it is converse of 7.6. It is just opposite of the theorem what I have just read in 7.6. Let's move to the 8th. What is happening? Yeah. Theorem where we have the sum of any two sides of a triangle is greater than the third side. Okay. So suppose that is a triangle. Okay. Two sides are there. Let us take a name as A, B and C. Suppose it is 7 centimeter, it is 12 centimeter and it is 14 centimeter. Suppose it is like that. If I take 7 centimeter this and this one also has to be 7 only, so again it is going to form a line itself, nothing more than that. We need a triangle, not a line. So that is the reason why if we add any two sides of a triangle, it is always greater than the third side. So this 8 theorem are really very important, and this thing will make your concept boom like anything. And if it goes on well, you can solve any questions from class 9th or class 10th. Okay, more concepts, but these are the important, very important. So let's recall them. One was angle side angle property. You remember that? Then came isosceles triangle property. Then came converse of isosceles. We are not going to use that right now. Isosceles is fine. Finally, after that we got side. Then what we got? Right angle hypotenuse side. Then 6th, 7th and 8th we have got something different. What we got in 6th? That angle side property, converse of angle side property, and finally side sum property. Okay, side sum property. We'll just recall them once and then we'll end the session here. First, angle side angle. So in two triangles, if the corresponding angle, then side, then angles are same or equal in measurement, then the two triangles are congruent. So that was our first part. Second, what we had is isosceles triangle property. In isosceles triangle property, what we can say is this isosceles triangle, the two sides are equal in length or equal in measurement, and thus what we can say, the angles opposite to the equal sides are equal in measurement. Third, converse, if the angles are equal in measurement, the side opposite to the angle will be equal. Side. In side, what we got, if the three sides of a triangle is equal to the three sides of another triangle, then that two particular triangles are congruent. RHS, right angle hypotenuse side. If two triangles each of 90 degree having the equal hypotenuse and one of the sides are equal, then we can say that the two triangles are congruent by right angle hypotenuse side congruency criteria. Now angle side property, again the same concept. If the angle is greater, the side opposite to the angle will be greater. If the side is larger, then the angle opposite to the larger side will be greater. Okay. Finally, side sum. What we got? If we add any two sides of a triangle, the sum is always greater than the third side. It is like that. So we have this 8 particular theorem, and they're really very important from your examination point of view. So don't miss it out. Don't forget to like, subscribe and share. So with that, we came to the end of our session. But we have learned many things, and really I'm very happy today that you have also learned it very well. So don't forget to like, subscribe and share, and take care. Okay, bye bye.